Good evening, children.
Yes, ma'am.
Good evening.
Good evening, ma'am.
Yeah, no energy at 8:20. All right. Children, I think we finished this in the last class. We have to continue from here. We finished till here. We'll have to continue from here. But anyways, we'll just recall the procedure for these two answers. I would like to bring the difference between the information given in these two questions. So both are regarding a field which is in the shape of a trapezium. Question number 6 and question number 7. This is question number 7. This is question number 6. In both, the field ABCD is in the shape of a trapezium. All the four angles are given to you. The angles of the trapezium are given to you. We have some more information. With that, we'll have to find the area of the four sectors. Question subdivision A is to find the total area of the four sectors. The total area of the four sectors. Not the area of the sectors individually. The total area of the four sectors put together. So you don't have to find the individual area. The total area straight away. The total area of the four sectors. So you know that the formula to find the area of a sector is theta by 360 into pi r squared. Theta by 360 into pi r squared. So using this formula, we'll find the total area of the four sectors. So theta is angle A, angle B, angle C, and angle D. For this sector, the central angle is angle A. For this sector, the sector angle is B. For this sector, the sector angle is C. And for this sector, the sector angle is D. Okay, so angle A by 360 into pi r square plus angle B by 360 into pi r square plus angle C by 360 into pi r square plus angle D by 360 into pi r square. Why are we using R, everywhere as why are we not writing R1, R2, R3, R4? That's because the value of the radius is the same everywhere. For all the four sectors, the radius is 14 meters. The radius of each sector is 14 meters. So if it were different, then we have to say R1, R2, R3, R4. But it's given that the radius of each sector is the same, 14 meters. So everywhere it is, everywhere R is 14. So pi r square, pi r square, pi r square, pi r square. So pi r square by 360 is common. So we have into angle A plus B plus C plus D. But we know that the sum of the four angles in a quadrilateral is equal to 360 degrees. So 360 cancels. So we have pi r square and then we take the value of R, 14. And the area of the four sectors put together is 616 meters square. And then the area of the trapezium, half sum of the parallel sides. Parallel sides are AD and BC. Half sum of the parallel sides, AD and BC, into the distance between them. See here, CD is not the distance between the parallel sides. AB is the distance between the parallel sides because distance is always the perpendicular distance. When we say, these two are parallel lines, the distance between these two parallel lines is the perpendicular distance between them, not any distance like this. See now, distance itself means perpendicular distance. So you cannot, some distance from here to here. This is not the distance between the parallel sides. This is not the distance between the parallel sides. Distance always means the perpendicular distance between the parallel sides. So CD is not the distance between AD and BC. It is the perpendicular distance AB because 90 degrees, you can see here 90, so perpendicular distance. So AB happens to be the side of the trapezium as well as the distance. AB also represents the distance between the parallel sides. AB is the side of the trapezium. It also represents the distance between the parallel sides AD and BC because it's 90 perpendicular distance. This one is 90. So into AB. So don't mistake it as into any side. It's half sum of the parallel sides into the distance between them. And distance is the perpendicular distance. So since it's already 90 perpendicular distance, So into AB. So here you don't have to find the distance between the parallel sides. AB itself is the distance between the parallel sides. So you can find the area of the trapezium easily because you know AD, BC and AB. And the area of the remaining portion, this portion, is the area of the trapezium, because the full thing is the trapezium, right? The full thing is the trapezium. The area of the trapezium minus the area of the four sectors. Minus the area of the four sectors. So this is about this figure where we know the distance between the parallel sides. But in the next one, we do not know the distance between the parallel sides. That is, we know that BC is the distance between the parallel sides, but the length of BC is not given to you in the question. Here, the length of AB was given to you. See here, what is AB? 30 meters. AB is 30 meters is given to you in the question. Apart from 55, with AD 55 and BC 45, apart from this, you're also given AB is 30. But in this question, you're given AB 75, AB 75, and CD is 50, CD is 50. Okay, so we have the length of the parallel sides. But what about the distance BC between them? It's not given. You do not know the length of the side BC, which means you have to find the distance between the parallel sides. We have to find the perpendicular distance between the parallel sides. And that is by the construction. So we draw DL. See, area of the four sectors, the calculation is similar to the earlier one. Angle A by 360, like this, B by 360. All right, so this one. So it's the same, it's the same, except that the radius is different. Okay, so area of the four sectors is similar to the earlier one. But here you cannot find the area of the trapezium directly because we do not know the distance between the parallel sides. So construction we draw. If it is given in the figure, now here it's already given in the figure. So I have not said construction. If that is not given, then you will have to draw DL perpendicular to, what is that? Perpendicular to AB. So it looks like it's given in the question itself. So you can see this DL is already there with dotted lines. If it is not there, you'll have to draw that. Then you should write construction, draw DL perpendicular to AB. Now you can see I've shown this this portion separately here, this one separately here. You can see it here. You can see it here separately. ALD, triangle ALD. This is A, this is L, this is D, triangle ALD. Okay, now our intention is to find the length of the line segment DL. What is the length of the line segment DL? So we're going to use trigonometry. To find the length of the line segment DL. Okay, so now we know that this full thing is 75. This one is 75, but this one is 50. Now this is a rectangle. This one is a rectangle. So opposite sides are equal. This one is a rectangle, so opposite sides are equal. So if this is 50, the opposite side BL is also 50, but the full thing is 75. So this will be 25. Is that clear, children? 50 and 25, is that clear?
Yes, ma'am.
All right, children. So now in which situation will trigonometry be handy, or will trigonometry be useful? Trigonometry can be used in any right triangle. Where you have two things known. That is, in any triangle, or in a right triangle, we have three sides and three angles. Any triangle has three sides and three angles. So in the right triangle, one angle is 90 degrees. Apart from that, you should know two other things. Not 90 degrees, that angle. Apart from that, you should know two other information. So in a right triangle, when you know any two things, see, we have six things, three angles and three sides. So in a triangle, in this right triangle, one angle is 90 degrees. Leave that. Apart from this, you should have two more things. It can be two sides, two angles will not be given because The sum of the three angles is 180, that we know. So when you know two sides or one angle and one side, you can use trigonometry. So because we know trigonometry connects one acute angle with two sides of the triangle. So see here, in this right triangle ADL, this one, you can see it here, ADL. What is our intention? We need to find the length of the line segment DL. What is known to us? This angle is 60 degrees. So we know this angle. And we also know the length of this side is 25 meters. 25 meters. So we know one angle and one side. So we can easily find DL. So in such cases, we can use trigonometry. See, we have a right triangle. Okay, so we can use trigonometry. We have an angle 60 degrees. We have an angle 60 degrees. And we also have another thing. This side is 25. This is sufficient for us to use trigonometry. So now connect what you know with what you want to find. Connect what you know with what you have to find. It's basically connecting the knowns with the unknowns. The knowns with the unknown. With the unknown. What are the knowns here? Angle A and the length of the line segment AL. What is the unknown? DL. DL is the unknown. So you'll have to connect these three things. You'll have to connect these three things. So you can, how is, with respect to angle A, how are AL and DL related? AL and DL related with respect to angle A. For angle A, DL is the opposite side. And AL is the, oh, so, yeah, so sorry, adjacent for angle A, 1 second. Let me start from the hypotenuse. So for angle A, for this angle A, this, for, sorry, in the right triangle, AD is the hypotenuse. This one is the hypotenuse. So now we have these two sides. We have this side and this side. For angle A, this is the adjacent side. So this is the opposite side. This is the opposite side. This is the hypotenuse. Now this is the angle. Okay, with respect to this angle, this is the adjacent side. Then this is the opposite side. DL is the opposite side. So this is not known. We have to connect these, opposite and adjacent. So tan or cot. Tan or cot. So tan 60 degrees is equal to opposite by adjacent, DL by adjacent AL, which is 25. DL by AL. Write AL here. DL by AL. Opposite by adjacent AL. So tan 60 is tan 60 is root 3. DL by AL is 25. So DL is equal to 25 root 3. So see, with the help of trigonometry, we found the length of the line segment DL, 25 root 3. Now you can proceed to find the area of the trapezium. Half sum of the parallel sides into distance between them. Find the area of the trapezium and then the area of the remaining portion, which is area of the trapezium 2 minus the area of the four sectors 1, 2 minus 1. We finished till here in the last class. All right, children. Any questions? Very disciplined class, you know.
No.
Okay, thank you. Okay, so we'll have to continue from here. I'm going to give you a test in some time. I have to finish this file. Yeah, once I finish this, I'll give you a test. Yeah. So I hope all of you have completed till here. I don't remember if I gave you time to work in the class or you were asked to complete later. I really don't remember, but we have finished till here. Yeah. Now here in this figure, ABCD is a trapezium. Look at the figure. ABCD is a trapezium. Okay. With AB parallel to CD. Okay. With AB parallel to CD. Okay. Angle BCD is 60 degrees. BCD. It's already given in the figure. BCD is 60 degrees. Fine. If BFEC. BFEC. Okay. This one. Okay. If BFEC. This is BFEC. This one. Okay, BFEC. If BFEC is a sector of a circle with center C, so C is the center. So that means CE and CB are the radii. See, a sector is a closed figure. You know that a sector is a closed figure. A sector is a region bounded by 2 radii and 1 arc. So see, C is the center. If C is the center, CE is the radius, CB is also the radius. And this is that arc which is a part of the circle. See, if you complete this, you'll get the circle. If you complete this, you'll get the circle. This is a part of the circle. This is the center of the circle. And this sector is a part of this full circle. So CB and CE are the radii. See, you can see that CB and CI. CB and CE are the radii. Okay. So remember that these two sides are equal because radius R. AB is equal to BC is equal to 7 centimeters. AB 7 and BC is also 7. BC, this one is also 7. That means this is also 7. AC is also 7. D is 4 centimeters. It's given that, see, EC is separately 7, okay? AB is equal to BC 7, AB is 7, BC is 7. If BC is 7, I told you, this and this radius. So EC is also 7, this one is 7. And DE is 4, DE, this one is 4. Then find the area of the shaded region. Find the area of the shaded region. So how will we find the area of the shaded region, children? What is the area? How do you find the area of the shaded region? Okay, so area of the shaded region is the area of the trapezium minus the area of the sector. Area of the trapezium minus the area of the sector. Area of the trapezium, you have the formula, half sum of the parallel sides. Parallel sides are 7 and 11. AB 7, DC 7 plus 4, 11. Into distance between them. Distance between them is not BC. BC is not the perpendicular distance between the parallel sides. BC is not the distance between them. So you have to draw this one construction, draw whatever, BF perpendicular to DC. Draw BF perpendicular to DC. That's a construction. BF perpendicular to DC is the construction. And again, using trigonometry, you should find the length of this line segment BF. Using trigonometry, you should find the length of the line segment BF from the triangle BFC. BFC from the triangle BFC. Use trigonometry and find the length of the line segment BF. So then you're good to go. You can find the area of the trapezium. And then you can find the area of the sector because theta is 60 by 360 into pi r square. R is 7. So area of the shaded region will be area of the trapezium minus the area of the sector. Yeah. Work this one, children. But let me do one thing. I'll give you time later. I'll give you continuously 20 minutes to work. Take a screenshot. We'll work this on now in today's class. For now, you take a screenshot. Yes, ma'am. All right, yeah. I'll see this one. Again, we'll have to find the area of the shaded region. You can see what is shaded outside the design. Outside the design, this design in the middle. Okay, there's a design here in the middle. Outside, this is shaded. You can see the gray portion, no, that is shaded. Okay, now the whole thing is a square. The whole thing is a square. You can see this is 14, this is also 14, this is also 14. This is clearly a rectangle. ABCD is a rectangle and opposite sides are equal. So this is 14, this is also 14. Like this is 14, so this is 14. This is 14, so this is 14. It's a rectangle. So opposite sides are equal, 14, 14. Now you can see all sides are equal. So it's a square. See, you can find the area using the formula L into B, length into breadth, or side square. Both will give you the same answer. Side square, A square, 14 square, or 14 into 14, length into breadth, 14 into 14, anything. Okay, so you can find the area of the square. Now you have to find the area of this design in the middle. This design in the middle. You'll have to find the area of this design in the middle. The difference, area of the square minus the area of the design is will be the area of the shaded region. The area of the shaded region is equal to area of the square, the whole thing, minus the area of the design. See, basically there are two things, okay? This is the shaded region. This is the unshaded region. This is the shaded region. This is the unshaded region. The whole figure ABCD minus the unshaded region will be the area of the shaded region, because shaded and unshaded together make the whole figure. Like boys and girls, boys, girls, class is equal to class. So this is like, say, boys. Outside we have girls, okay? And the whole thing is the class. So class ABCD minus boys will give you the number of girls. Or the class ABCD minus girls will be the number of boys. This is shaded. This is unshaded. Shaded plus unshaded is the whole figure. Shaded region plus the unshaded region is the whole figure ABCD. So from ABCD, if you take away the area of the unshaded region, you will get the area of the shaded region. So how do we find the area of the unshaded region? So though nothing is mentioned, you should take them as semicircles. These are semicircles. Now, like there is no question about that. These are semicircles. And these are the diameters. These are the diameters of the respective semicircles. These are the diameters. And diameters, they're equal. All these four are equal. So this one is a square. What is in the middle is a square. This one is a square. And on each side, there's a semicircle. On each side of the square, there's a semicircle. Okay, that's how you understand the design in the middle. That's how we understand the design in the middle. The design in the middle is a square, is a square, is a square. And on each side of the square, there's a semicircle. Each side of the square, there's a semicircle, semicircle, semicircle. Now, how do you find the area of the, how do you find the area of this portion? It will be the area of the square. It will be the area of the square plus find the area of one semicircle into 4. Find the area of one semicircle into 4 will be the area of 4 semicircles. 4 semicircles and the area of the square. So the area of the square plus the area of the 4 semicircles will be the area of this region, this design. Then the area of this whole thing, the big square minus unshaded will be the area of the shaded region. Now to find the area of the design in the middle, design in the middle, you need to know the side of the square, this one, which is also the diameter of the semicircle. For the square, you need the side, which is the diameter of the semicircle. And for the semicircle, you need radius. For the semicircle, you need the radius. So in all, you'll have to find the length of this one. If you get this is the diameter, and half of the diameter is the radius. If you get this length, if you get this length, that is the side of the square. And half of that will be the radius of the semicircle. And it's very simple. Now see here, what is this total length from this end to this end? What's the total length? Please answer this. What is the length from here to here?
14 centimeters.
Very good. Okay, 14 centimeters. The length end to end is 14 centimeters. Now, how can we break down 14? This one is 3. This one is 3. From here to here is 3. So 3 plus from here to here, this not from here, children, actually. It's like this. This is the center. This is the center of the diameter. Center of the diameter. So let me take the line through the diameters. Sorry. This is center of the circle or the diameter. So we are basically taking this line. This one is 14. This one is 14. So what is this made up of? This is 3. This is 3. Plus this one is the radius. Plus this one is the diameter. Plus this one is the radius. Plus 3 is equal to 14. Is equal to 14. See here, 3 plus this is the radius, because in a semicircle, semicircle, from here to here is the radius. And this one is the diameter. This one is the diameter. In a quadrant, both are radius. In a quadrant, this is R, this is also R. But in a semicircle, this one is the diameter. That is R here and R here. This is the diameter. And from here to here is the radius. So this is R, radius, this is radius. 3 plus R plus this is the diameter, or you can say 2R. Diameter or twice the radius, 2R you can say. This one, 2R plus the radius plus 3 is equal to 14. Or you can also do this. You can take this one like this from here. You can take this. So this is 3. This is the radius. This is twice the radius. This is the radius. This is 3. The sum of all this is equal to 14. So like that you can find R. You can find R, and you can also find the side of the square, which is 2R. That's all. So how have I found the area of the 4 semicircles? One semicircle is half pi r square. Area. Circle is pi r square. Semicircle is half into pi r square. This is for one semicircle. For 4 semicircles into 4. See, that's how you write. You don't have to memorize 4 into half into pi r square. Just start writing from behind. Start writing like this. Circle is pi r square. A semicircle is half into pi r square. Like this, you have 4 semicircles, so into 4, right from behind. So that's what it is. Yeah, children. That's all. Take a screenshot. I'll give you time in the class to write this. Take a picture. Done, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Very good. Yeah. Now tell me. Read the question and tell me your idea to find the area of the shaded region. The whole thing is shaded. Tell me your idea to find the area of the shaded region. That is idea meaning like we did here, we had to find the area of the big square minus the area of the design will give us the area of the shaded region. Like that, I want only the idea. I don't even want the formula.
Ma'am,
Yeah.
area square plus area of major sector into 2, ma'am.
Very good. Area of the square. Area of the square plus the area of the 2 major sectors. What is the sector angle? What is the major sector angle?
90 minus 360. ma'am.
360 minus 90. Very good. 270 degrees. Very good. So how do you, understand this figure? It's basically a square here. Okay, there's a square. There's a square. And see the design? The full thing is this one. See here, like this. There's one piece like this. And there's another piece like this. This region is already included in the square. This region and this region is already included in the square. You don't have to, it is not the area of the square plus the area of the 2 circles. It's not the area of the square plus the area of the 2 circles. It is the area of the square plus the area of the 2 major sectors. The area of the 2 major sectors. This one is 90. So this will be 360 minus 90, 270 degrees. This is 90. So 270 degrees. So the area of the square plus the area of the 2 major sectors, 270 by 360 into pi r square, will give you the area of the shaded region. This is 270. 270. This is also 270. Area of the square. So don't find this area. This is already there in the square. This area is already there in the square. Don't repeat it. This is already there in the square. So area of the square plus the area of the 2 major sectors with sector angle 270 degrees will be the area of the shaded region. Take a picture, children. Now you may have a doubt, a major sector, the formula is 360 minus theta. That's okay. See, for theta, I've substituted 270 directly. Now, because that's how we have learned, no, area of the major sector is equal to 360 minus theta by theta into pi r square. If you want to write this formula, you must write 90 here. 360 minus 90. You can understand that. I've written theta by 360 into pi r square, but theta I've taken directly 270 degrees. I've taken 270. If you want to write this formula, 360 minus theta by 360 into pi r square for major sector, please write that. But your theta will be 90 there. 90. This is 270. 360 minus 90, 270. So don't get confused. Don't think this is the formula. Anything you can write. Substitute the value correctly. Yeah, take a picture, children. Done, children? Took a picture?
Yes, ma'am.
Yeah, good.
Yes.
All right, children. This one, I want you to work first because when you work, you get an idea. You understand something, or maybe you understand the whole thing, whatever be the case. So then I'll explain. Take a picture. So 1, 2, 3, 4. Four sums. How many of you are there in the meeting? 7. Use the emoji. Raise your hand, children. Ramanathan, Sashmi, Nandini, Ananya, Harini, Sneha, Priyanka, and Tarun. Okay, fine. All right, children. So please understand, you're not blindly copying. It's not just writing out this in your notebook. Please understand. Go through the working. Understand what you're writing. First understand and then write it and then complete it in your class workbook. I think I can give you 5 minutes for this. Okay, fine. I'll get back to you in some time. You've taken the screenshots for everything. Start working from here. And all of you must work and share the pictures with me. Otherwise, I'll remove you from the meeting. See, all this threatening, I actually don't know. I just want to make sure that all of you complete it and share the pictures with me. All the 8 of you present in the meeting must write this in your book and share the pictures with me. And then we'll continue. So with that, we come to the end of this file. We'll go to the next one. Finish the first one, send the picture. Finish the second one, send the picture. Third one, picture. Fourth one, picture. Yes, get started. Mark your doubts and you can ask me later. All right, I'll get back to you in some time. So at the end of 20 minutes, Ram has sent the pictures. Nandini and Priyanka sent only one sum, but that's too less for 25 minutes. You should have finished at least 3 of them. What about the others?
Ma'am, I finished 3 sums.
Okay, share the pictures.
All the sums from I'm sending it.
Okay, fine. Shreyas? Shreyas? Sashmin? Harini and Sneha? Okay, I'm waiting for the pictures. Please share, children. I'll give you another 5 minutes. Very good, Ram. Very good. Yes, Ananya, waiting for your pictures. Nandini, Priyanka. Yeah, Tarun has sent. Good, Tarun.
Ma'am, I have doubt in question number 8.
Yeah, sure. 8. Yeah, yes, Tarun, what's your question?
Ma'am, area of trapezium, I got different answer, ma'am.
Maybe I've made some calculation mistake. Let me check. Is this one correct? PM? Is this value correct?
Yes, ma'am.
Okay, this trapezium area, is it?
Even I got a different area, ma'am.
I'm so happy that you all calculated by yourself and not taken it down from the screen. That's very nice. Priyanka and Tarun, very good. Half sum of the parallel sides, 7 plus 11 into distance between them. Okay, so then half 18, 7 by 2. What have I done? 63. So 2 1s are 2 9s are 9 7 is 63 into 1.73 by 2. 63 into 1.73 divided by 2. Oh, yeah, 54.495, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, correct. 54. Maybe I used 1.732. I'm not justifying, but let me check what I've done. Into 63 divided by 2. Yeah, I've calculated by mistake. I've used 1.732. When I use 1.732, then I get 54.558. But yeah, here it is not 54.558. It is 63. 54.495. Okay, so then this one also will be. What about this answer? 25.666. Is that correct?
Yes, ma'am.
Okay. So it will be 28.829. Correct? 28.829 centimeters square. Okay, good. Thank you. What about this one? Any questions here? Okay. This one?
No.
All right. So got it from Priyanka. Very good, Priyanka.
Sorry, ma'am, I sent the same thing twice.
Yeah. Ananya.
Corrected the area of trapezium, ma'am. Should I send it again?
Ananya, yes?
I corrected the area of trapezium now, ma'am. Should I send it again?
No. Okay. Priyanka, Ananya, Tarun, Ram, Nandini. Yeah. The last one you're working, Nandini?
Yes, ma'am, I have finished working. Just I am searching for my mobile.
Okay, fine. So see, the others have not responded at all. Harini and Sneha, huh? I don't know why it's showing on hold. You put yourself on hold, is it? Anyways, they can't hear me. Nandini, okay. So who's not responded to today's meeting? Ram, Ananya, Priyanka, Harini, Sneha. Sashmin. Sashmin has not responded. In spite of, giving you the instructions, there's been no response. All right, let's proceed to understand the last one, children. Just wait for some time. If you're still completing this one, just wait for 3 minutes. Still writing or done, children? All right, let's understand this one. So in this figure is given to us, and along with it, we have some information regarding the figure. Let's read them. So in the given figure, AB is 36 centimeters. AB. Okay, so this is 36. So this is a semicircle that sits on the diameter AB. AB is 36, which means the radius of this, big semicircle, the radius is 36 by 2, 18 centimeters. All right. Now, what do we have in this figure actually? There is one big semicircle, and inside that there are two semicircles. Two semicircles meaning two equal semicircles, and there's one circle also. So in this big semicircle, there are two identical semicircles and a circle. Now we have to find the area of the shaded region. That is the area which is outside these two semicircles and the circle. Area of the shaded region. So clearly the area of the shaded region is area of this big semicircle, minus the area of this semicircle, minus the area of the semicircle, minus the area of this circle. Or in other words, we find the area of this outer semicircle and we'll have it. We'll find the area of this outer semicircle, have that. Then we'll find the area of this one, and this one, and we'll find the total. We'll add this area plus this area plus this area. Now, the area of this semicircle minus the sum which we got will give you the area of the shaded region. So that means we need to know the diameter of this semicircle, radius of this semicircle, which is given to us, 18 centimeters. We need to know the radius of this semicircle. Radius of the semicircle also we know, because the whole thing is 36. So half of this is 18. So half of that will be 9. It will be 9. See here. This full thing is 36. So the 18 here and 18 here. 18, 18. Now these are two equal semicircles. So the diameter of the semicircle is 18. The diameter of the semicircle is 18. So the radius will be 9. The radius will be 9. So which means you know the radius of the outermost semicircle, 18. You know the radius of these two small semicircles, 9, 9. What about the radius of this circle? What about the radius of this circle? That's not known to us. That's not given. So we have to first find the radius of the circle. And then you can find, the areas of the semicircles and the circle, subtract and get the area of the shaded region. So this is what you need to first analyze. What is given? Is it sufficient? Or what other information you need to complete the answer? So analyzing that way, what you understand, you have the radius for the outermost semicircle. You know the radius of this semicircle, this semicircle. We do not know the radius of this circle. So we have to first find this. See, I repeat, this whole thing is 36. So radius is 18, 18, 18. Radius is 18. Then for this semicircle, the diameter is 18. So radius will be 9. Here also the radius will be 9. So for all the semicircles, we have the radius, but for the circle, we do not know the radius. So we have to find the radius of this circle. Okay, fine. So this is the construction. Mark of a point R. Now you should mark this point R such that excuse me, children. Yeah, thank you, children. So now we need to take this point, mark this point R, in such a way that, you can connect these 3 points are collinear. R, C, and M are collinear. We already have C and M. We already have C and M. We already have C and M. So you should take a point R such that these 3 points are collinear, M, C, and R. MC you can join. MC you can join. When you continue like this, where it touches, that is R. See, you join MC like this, okay? You join MC like this. When you produce it, this is R. This is R. Okay. So join CM, join CM, CQ. See, I've taken those points. Okay, I've taken those points P and Q. So join CQ and join CR. Join CR. So we have to, what is this point R? Maybe I can write that for you. Construction, join CM, join MC and produce it to meet the semicircle, the outer semicircle at at R. All right. So join MC and produce it to meet the outer semicircle at R. All right. So then in that case, it will be only join CQ. In that case, it will only be join CQ. Join CQ. Okay, let me take out this construction and write this. And then join CQ. So join MC and produce it to meet the outer semicircle at R. Okay, and then join CQ. Join CQ. So remove this construction, do that correction, children. Remove this one and write this. All right, I hope it's done. Now, you might have learned this chapter at school. Well, we haven't still done it. We are still to do it here. So there's a theorem between the circle and a tangent. That now, supposing we have a tangent to the circle at this point P. Okay, and you draw a radius through the point P. P is called the point of contact of the tangent with the circle. And through this point P, when you draw the radius, when you draw the radius through the point of contact P, the radius will be perpendicular to the tangent. Circle, tangent. Okay, so we know that tangent is a line that touches a circle at exactly one point. So let's say the point of contact. Point of contact is a point where the tangent touches the circle. So let's say it's P. Now through the point of contact P, when you draw the radius, through the point of contact P, when you draw the radius, that radius will be perpendicular to the tangent. That radius will be perpendicular to the tangent. Okay, so now you can see here, this is the tangent to the semicircle. Okay, let me complete the circle. That will be more clear. Okay, I'm considering this line. Okay, this line, all right. So line segment, you can also produce it. Okay, and then complete the circles to understand. Okay, let's complete the circle. Now you can see this is the radius. This is the radius. M is the point. This is the tangent. We are considering this as a tangent because it touches the circle at M, and through M we have this radius MQ. So the radius MQ will be perpendicular to the tangent. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
All right. Let me just repeat that. So this line acts as a tangent to this circle, So this line, which is a tangent to the circle, touches the circle at M. M is called the point of contact. And you can see MQ. Okay, MQ is a radius through the point of contact M. So we know that this radius will be perpendicular to the tangent. So 90 degrees here. So you know if this is 90, this is also 90, but it's enough to mark 90 here. Now we have a right triangle. See why all this? Because we understood, we analyzed that we do not have the radius of the circle. We have the radius for all the three semicircles. We do not have the radius of the circle. So this is to find the radius of the circle. All right, now we have a right triangle CMQ. We have a right triangle CMQ. Now using this right triangle and using Pythagoras theorem, we are going to find the value of R. All right. So how much is CM? How much is CM? Now what is R? R we are calling the radius of this circle as R. Okay. R is the radius of the circle. R is the radius of the circle. All right. Now how much is CM? How much is CM? CM is how much is MR? How much is MR? MR is what is MR? MR is the radius for the outermost semicircle. So let me complete the circle. It's not going to be very good either. Yeah, okay. I have completed the circle, children. I've completed the circle, and you can see that this is the radius of the circle. This is the radius. How much is the diameter given? 36. The diameter is given to be 36, which means the radius is 18. The radius is 18. Radius is 18, okay? So this one, MR is the radius. MR is the radius. For which one? For this circle. For this circle. For this circle, this is the center and MR is the radius. Okay, which is 18. The value is 18 because AB is 36. The diameter is 36. So this is 18. 18, 18 minus R. This full thing is 18. Minus R, which is CR. CR is the radius of the circle. Minus R will be equal to CM. See here? This full thing is 18. MR is 18. And this portion is R. Okay, this portion is R. So the remaining portion CM is the whole thing 18 minus R. 18 minus R. That's what you can see here, 18 minus R. So we found this side of the right triangle. We found the expression for CM. Next is MQ. MQ is 9. We know that already because MB is 18. MB is 18. So half of 18, 9. MQ is 9. MQ is 9. So we know that this is, or rather we have found that this is 18 minus R and this one is 9. Now what about CQ? What about CQ? Okay, let's break it down. CQ is nothing but CF plus FQ. CQ is nothing but CF plus FQ. What is CFR? How much is FQ? 9, because it's a radius, right? See, from here to here is a radius. CF is the radius. Center to any point of the circumference. You complete the circle. If you have a doubt, you just complete the circle. This is 18. The diameter is 18. So the radius is 9. The radius is 9. Okay, so we break down in CQ into 2 line segments. Break down CQ into 2 line segments. CQ is made up of CF and FQ. How much is FQ? 9. What about CF? It's a radius of the small circle R. So 9 plus R. So like this, we find the expressions for the 3 sides of the right triangle. Now we use Pythagoras theorem. And when you expand this, be careful. A minus B the whole square is A square plus B square minus 2AB. A square, B square, 2AB. A square, B square, 2AB. Don't forget the 2AB term. So when you work that, you will get the value of R. R is the radius of the circle. Then the rest is easy for you. You know how to find the areas of the semicircles. Use the diameter, use the radius carefully. That's all. Use the radius carefully. Yeah. So now finding the area of the shaded region is not a difficult task for you. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Harini, Sneha, why you didn't share the pictures?
Ma'am, I will share it now, ma'am.
Okay, after the class, fine. You have completed, both of you?
Yes, ma'am.
Okay. Okay, you had put yourself on hold, is it? Some time back? Or was there any internet?
Yes, ma'am. Internet issue, ma'am. Call came and then we didn't know that.
Okay, you received a call and you didn't know that your the meeting was put on hold, is it? Oh, fine, fine. Now I
Yeah,
understand. I used to always wonder why that happens. I think somebody else also has mentioned this earlier, Kanishka. sorry, I forgot. Now I'll not ask you again. Yeah, but be careful, huh? Because what if I was talking something during that time and you were not able to hear me?
ma'am, but we understood.
Okay, fine. No, I was not talking anything at that time. I'm just telling you.
Okay, ma'am.
All right, children. So I told you we make use of this right triangle. We make use of this right triangle to find the value of R. We use Pythagoras theorem here. For that, you need to get the expressions for these 3 sides. And how does it become a right triangle? Using the theorem that the radius through the point of contact is perpendicular to the tangent. Okay, so this becomes a right triangle. And we find the expressions for the 3 sides. Pythagoras theorem, value of R, and then everything is easy. Everything is easy. Got it, children?
Yes, ma'am.
Yes, ma'am.
Very nice. Same file. Yeah. Yeah, this is your homework. Please complete these answers by the next class. Very simple questions these are. Okay. Maybe you will need 1 hour at the most to complete this. See, if you do it as homework and when we discuss the answers, if you've made any mistakes, things will become very clear to you. You will realize your mistake and, be very clear. But if you don't complete the homework and you just listen to the explanation, then you need to work, practice that once again to really register that. Please complete all these sums as homework and we'll discuss the answers in the next class. Took a screenshot, children?
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you,
Good
ma'am.
night. Good night, children.
Thank